Hi everybody, good morning, good afternoon, good evening, depending on where you are, and thanks for joining Zero to Hero in Agile Function with Java. So my name is Daniel O. I'm going to talk a little bit about how to build your Java application for serverless workload, specifically in Agile Function. In the end, you're going to deploy this serverless function with the Java application across serverless platform. You're going to make agnostic serverless function, not only Agile Function, but also you can deploy this application function into Kubernetes as well. Let's get started. Just a quick introduction about myself. My name is Daniel O. I'm working for Red Hat as a technical marketing major slash developer advocate with a specialized in cloud native runtime, for example, Quarkus, Spring Boot, Node.js, etc. I spend a lot of time to create a common practice how to build serverless and service mesh integration with the cloud native application. I'm also responsible for CNCP ambassador, which allows me to build a lot of cloud-native architecture and a build practice for application developer as well as SRE and DevOps engineers. And here's my quick contact information. You can follow my Twitter and Github, as well as you can subscribe my YouTube channel. I already published more than 100 technical video and technical tip and tutorial, etc. Okay, move on. Let's take one step back, try to understanding why we need to think about Java as the application workload on the serverless. So traditionally, you probably understand if you already have more than 20 or 15 years of development experience with the Java technology. So at a time almost decades ago, in technically 26 years ago, Java unleashed upon the world to implement your business requirement. You can have a high network traffic and throughput based on Java application across the multiple application server, regardless of the slow startup time and high memory resource consumption. But you can also have a dynamic flexible behavior of a Java application, which allows to run your business application across app server over the internet, which is really great at a time. But things change that. So runtime environment, we already moved forward to immutable infrastructure, aka Kubernetes, which you have to run even single microservice application with high scalability, which means you have to scale out based on-demand traffic, sometimes the 100 application pods, sometimes the 100K application pod at the same time with the same business capabilities. With that, change trend and infrastructure change that dynamic behavior of a Java application. That's not a good capability in this era. So that's why people say Java is too heavyweight or too slow for container technology with Kubernetes, specifically serverless architecture. This is a reason why Quarkus was born and designed for optimizing container strategy and running on more high scalable, fast startup, and small memory footprint on the Kubernetes. Not only cloud-native microservice application, but also serverless application with the event-driven architecture. So here's a quick illustration describe how to get started the Quarkus application development from zero to hero, specifically Kubernetes and Java application implementation. So as you say, if you are a Java developer, you can start from left side. Okay, you got a lot of issue or change for run the application on immutable infrastructure like a Kubernetes with small memory footprint and startup time. You got to reduce the memory footprint, and then you got a fast startup time and a small disk footprint. And then it's all kind of challenging came from a containerized application. You can also optimize your existing Java application running on serverless platform like a Kubernetes or Microsoft Azure. So which is really good opportunity for Java developer to make better developer experience to run your existing Java application to serverless workload, because there are more than a million Java developers out there around the world to solve business requirement as well as maintaining existing critical business application every single day. So Quarkus actually get rid of a lot of existing mandatory work at runtime and shift into build time. As an example, in the right side, the traditional Java framework, you got to compile the application and a provisioning, which means you can enable, disable specific capability or feature, and then rescan descriptor, and then try to parse annotation, etc. It kinds of all activity actually happening at runtime behind the scene when you run the Java application running. But this is an unnecessary thing whenever you run the application as a pod starting. So just imagine that if you scale out 1,000 microservice application, you need to repeat this kind of stuff 1,000 times, which is definitely not effective and productive way for application deployment and even designing or development on your Java application architecture on Kubernetes. The Quarkus provides a lot of extension. Also, you can understand one of the capability such as Maven dependencies, which allows you have enterprise capability for your business application. With that, so Quarkus 100% designed for container first strategy. So it's a quick, interesting example how to describe your resource density for your application running on the Kubernetes. So in the left side, the green four boxes just say there are four traditional cloud level Java stack. For example, Spring Boot application, you can just deploy 4 Java application pod on the Kubernetes worker node. And then you have a double high density for Node.js application and maybe triple time high density with the Go application. This is the reason why a lot of people in the enterprise developer and architect really prefer to use Node.js and Go for Kubernetes, specifically serverless application worker nodes. But Quarkus actually provide two options for developer to packaging application like a job file, the traditional way running on JVM, but the other way, Quarkus also enable Java developer to packaging application as a native executable file. You don't need to run application on top of the JVM. Instead, just running on immediately just executable file like a Go and Node.js. And with the dead native compilation and executable file based on Quarkus, you can have almost the same resource density like a Go on Kubernetes worker node, which is really awesome, specifically a serverless as well as a cloud native Java application, just like a general worker node as well. So here's the evidence when you run Quarkus application on Kubernetes with some multiple use cases. For example, Quarkus with the native executable, you have just 12 megabyte for memory footprint with the JVM 73, but traditional cloud native stack like a Spring Boot just 136, almost 10 times less than your memory footprint with the Quarkus and native executable file. What about the faster start time? This is a really interesting fact for serverless application. So with the Quarkus and native, you just need to 16 millisecond to start like just a RESTful API, like a single app microservice application. With the JVM, less than 1 second. A traditional cloud native Java stack with a 4.3 second. This is a big reason and concern for many enterprise developers when they adopt the serverless architecture with the Java technology, because there are cold start for each cloud provider. Maybe you need to start up time 4 seconds to cold start, which make your end user feel some kind of latency with the unsatisfied your application capability. So in a small memory footprint, I already explained that thing. This is all kind of benefit of Quarkus for serverless application, but also traditional business application on Kubernetes. One of the benefits of the Quarkus actually provide multiple and more than 400 extension. And one of the extension, as you can see, Azure Cloud Extension, which allows Java developer to build your application to Azure Cloud directly. Also, there are Azure function related extension, which you can package your Java application, fitting in Azure function and deploy Azure directly. There are 3 options. I'm gonna go through what kind of option you can have in the next live demo in a minute. And there are Quarkus Funky. So Quarkus Funky is actually standard portable Java API for developer to write a code as serverless function, and you can deploy the multiple serverless platform, for example, Azure and Kubernetes or even Google, etc. So once you create this Quarkus function serverless function, you can deploy more flexible and dynamically, just like a hybrid and a multi-cloud strategy. Okay, let's get right into the demo, how it works. So first of all, maybe you can go to code.quarkus.io. It's easiest and fast way how to get started Quarkus application development. And then you can select any extension you want to add it in your Quarkus project. For example, you can key in Azure in the search box. You can find the multiple Azure related extension as you can see. So you can select whatever you want and it just generate your application. It will download it as G file and then you just unzip and then open your ID tool, whatever you need, like IntelliJ, VS Code, something like that. But today, I'm not going to try to use that, but instead, you can actually use your Maven command line to generate your new project, such as this command line. I'm going to generate a new artifact based on Maven command line, and here's the group ID and artifact ID, and also there are project name Quarkus Azure Fungal Test, and I'm going to use the latest Quarkus version at this moment, 2.8.1 final. And just to return to command line, it automatically generates a new project, like a Maven project. So you can see there are a lot of parameters already set in on your POM XML in the end. So I'm going to change the right directory and then open this project based on my ID tool, VS Code. Now let's go to explore this project first time. And here's the POM XML. You can see the latest version 2.8.1 final. And here's a bunch of the property configuration for Azure Cloud. And here's a couple of the Azure configuration. And for example, function application name, function app region, and the West EUS, and then a bunch of the stuff here. And here's the 4 different types of application, how to implement your function and deploy Azure function. You can use the just REST easy, just a general RESTful API application. You can also use a servlet based on Undertow, or you can reactivate application based on Vertex. But we're going to use a funky, which allow me to have more flexible function application for my hybrid cloud storage at the end. But we're going to deploy this application to Azure function today. But in the end, you're going to deploy this application any serverless platform. So I'm going to delete the other extension. I'm going to use only funky annotation at this moment. And then go to application. There are already generated multiple serverless function, but I just delete all resources file except for greeting function. Now, when you go to application property file, you can see we just set the root path API because the Azure function expect the API is a default endpoint you access Azure function. So here is the test unit because Quarkus provides continuous testing capability for developer, which means you don't worry about integrate any third-party tool for your test-driven development. So I'm going to delete the unnecessary test case here. For Vertex, I'm going to servlet and just RESTful API. I'm going to just repeat test funky. And then, as you can see, there's funky hello, just a single application. So I'm going to start Quarkus dev, which is Quarkus development mode, and it give me a live coding capability, which is really awesome because it's not only for the serverless application development, but also you can develop any kinds of application on Quarkus. It allows me to have live coding, which means you don't need to recompile, rebuild, restart your application while you keep changing the application. So I'm going to access the endpoint like API funky hello, which is endpoint is exactly the same name of your method name. So this is the method name funky hello. So I'm going to return hello funky, which is really cool and easy way. I'm gonna press D from that runtime. You can go to Quarkus Dev UI. It showcase a lot of graphical way, like some of the configuration editor. You can change the editor from Dev UI. It automatically changes your local file system, aka application properties file. And you can open a read-only terminal. It shows the runtime logs dynamically. And then you can see test running, which is continuous test not started. And you can press R from the runtime. It automatically continue testing started, and then you have a test case succeed with a green color because we have only one test case here. So let's try to change the return text file from hello funky to hello my function for Azure. And I just save a file and go back to terminal, and you can see automatically detect your test case will fail by Quarkus continue testing capability. And then when you go to dev UI, you can find the same result, your test case will fail, which is really awesome. I don't even rebuild, recompile, and restart my application runtime because Quarkus automatically make that happen just like automatically. And then when you go back to test case and change the return text, just like my actual code in a save file, and then as you can see, the terminal window automatically detecting your test completed with succeed. And then when you go back to WY, you can have the same result, which is really awesome. So people saying, wow, this is really awesome, but what if we could add a new class or method, it'll be still live coding working? Let me show you that thing real quick. So I'm going to add a new CDI bean, the greeting services, which is Quarkus provide 100% CDI injection. So here is a new service, something like a greeting with a parameter and pass down that. So welcome to Quarkus Azure function at JCOM 2022 with the add actual parameter name. I'm going to inject the CDI bean. So exactly the same thing on the wire, just like a Spring Boot, but with a more explicit term like inject my CDI greeting services Java bean. I'm going to add a new function with the func annotation, which allows me to make a standard portable Java API in the end. And then the greeting service, and then I'm going to return call the greeting service CDI. And then I just call the new endpoint such as greeting, and then pass down like my name is Daniel O. And return that, and you can see welcome to Quarkus Azure function at JConf. JDCom 2020 Daniel O, which is really awesome. In the meantime, I never ever tried to recompile, rebuild, redeploy this application, and restart my Quarkus runtime. In the end, automatically Quarkus detected to change the code and redeploy my actual runtime. It will increase the developer productivity, and the developer only focused on application development rather than the boring in-loop development process. I'm going to try to stop my dev mode, and then now I'm going to deploy this application to Azure Function directly. In order to do that, I'm going to use Azure Function plugin to deploy this application, which will packaging application and create multiple necessary resources in Azure Cloud and then deploy Azure Function in the end. Let me try go to PalmXML, how the Azure Maven plugin looks like. And you can see here the Azure Function Maven plugin. And then in my case, I'm running this demo on my Mac OS. That's why I'm going to change it to OS to Linux. And then here the app name and the region name. I already configure my configuration. Go back to here my Azure portal in a function app. There's no function app at this moment. And I just refresh just to make sure there's no function app. I need to make sure login my Azure Cloud AZ login, and then it brings to open new browser and then login, and then you can see I just login. And now I'm gonna run this Maven install command line, which will create some kind of resources. For example, when you go resource group, you can see the Java function group. I already deployed several times ahead of time, which means it's a resource group already created. But when you try to first deploy this function, it automatically creates the resources group. And then if you're already there, it already reused the resources group. And then you can see application inside also created, which means in the end, you could trace all kind of event in your function apps. And then the creating new deployment, and you can see deploy successfully, deployment done. And then when you go to Azure portal and try to refresh, and now we have a new function app on Azure Cloud. Click on detail, and you can find the URL and the metrics and so on. There's no request at this moment. Let's try to click on the URL and go back to terminal window. Now your Quarkus trigger URL based on HTTP, and the starting with API, and the path means your actual function name. Back to the Azure portal, and let's try to access the default URL. And you go to click on that, and your function is up and running. Okay, which is really awesome. And then try to access that URL, and let's try to first function the funky hello. And then you can see the hello my function for Azure is just return as we saw in my local environment, and try to another function like a greeting function with a parameter like a Daniel O. You can find as a return code just like we saw in my local environment. You can also access the function endpoint using web browser like a API funky hello, and you can find the same result hello my function for Azure, which is really cool. And then let's go to log stream because inside already application inside already created during the deployment, and then try to call another function like a then-all, and then you kind of return code, and then when you go back to log stream with the inside, you can find the dynamic logo, and then when you go back to overview, you can find memory working set and a function execution count and a memory millisecond. You can find more metrics. It will take some time to aggregate kind of metrics from the Azure cloud, and then this is a really cool thing. You can deploy the application from Quarkus to Azure function directly, and then in the end, it automatically creates the resources like a resource group and an application inside and a function itself as well. And when you go back to log stream once again, you can have a lot of event messaging and logs you can find in the application inside log. Once again, just pin the URL Daniel TV or scan QR code. You can find my YouTube channel. I push a lot of technical demo video around the Quarkus and Kubernetes and the serverless and function, includes this video as well. And then please make sure and feel free to subscribe to follow more upcoming video and technical demo. Okay, quick summary of this session today. So you will learn about why we need to think about Java workload to still fit it in the serverless application deployment on the Kubernetes as well as a function. Because you know what, Java was designed and born almost 26 years ago for high network throughput as well as a small startup time and quite a amount of a memory footprint. But at the time, this is a really cool thing. But after changing infrastructure for Kubernetes, that's not a big benefit for any longer. Since Quarkus was born, it's totally changed. And a lot of people really prefer still use Java workload and Java application stack for serverless, but also client-level microservices application. Because Quarkus enable Java developer have small tiny packaging application with a container as well as like a native executable. With the Quarkus developer have two choices to build application as Java file but also native executable, which make us a small and tiny serverless application on top of the Kubernetes as well as a public cloud such as Azure cloud. In the end, you can keep using your Java technology stack for improving your business application, but also maintain existing enterprise Java application and so on, not only for serverless application, but also existing enterprise Java application. And also, you already saw in the live demo, the Quarkus gives a lot of developer experience, such as live coding. You don't need to rebuild, recompile, restart, and redeploy your application while you keep changing your code for business application. As well as you can have a dev UI for the graphical GUI to showcase a lot of extension and the dependency you actually put into your Quarkus project. And the continuous testing, one of the great features of the Quarkus, which allows Java developer to have test-driven development practice. So whenever you change the code, you need to make sure everything is okay. You test the code, which could avoid some of the big mistake when you push your mistake code into your centralized Git repository. It automatically deploys to production environment in the next 3 minutes due to the great CI/CD pipeline. But if you could have a continuous testing capability inside the Java framework just out of a box, which is really comfortable Java developer to more focus on application development rather than testing or rebuilding, and just like a loop development process. And last, at least, the Quarkus Funky, one of the extension on Quarkus provide the Java developer to have flexible and portable serverless function based on business application. Once you write that serverless application and deploy any serverless platform such as Azure Function, AKS as well. Thanks for watching. Enjoy the rest of JDConf 2022.